All right, let's talk about React. We all use it, right? We click a button, stuff on the screen changes, it just works. But what's actually happening under the hood? Between that one little click and the pixels changing on the screen? Well, it turns out React is performing this incredible, high-speed ballet of operations. Today, we're going to pull back that curtain and see exactly how it all works.
So let's start with that big question. You call setState, or you use your state hook setter, and then what? It can feel a little bit like magic, but I promise you it's not. It's a super predictable 5-step pipeline. And understanding this pipeline, that's what separates a good React developer from a truly great one, especially when you're in a technical interview. So here's our game plan for this explainer. We're going to follow the journey from that initial click, walk through the 5 core steps React takes, see how it builds its virtual blueprint, and then get into the really cool part, the difference between planning the work and actually doing it. And we'll wrap up with some key takeaways to make sure you absolutely ace your next interview.
Okay, so let's get that high-level roadmap in our heads first. Because here's the thing. Every single time you update state or props in React, it kicks off this exact same 5-step journey. Every single time.
Here they are. First, there's a trigger, like you changing the state. Second, React creates a brand new virtual DOM. Third, it does something called diffing to see what's changed. Fourth is reconciliation, which is basically planning the updates. And finally, the commit phase, where it actually writes those changes to the real browser DOM. You can kind of think of it like ordering a pizza online. You trigger the order, the kitchen gets the new details, compares it to your last order, plans how to make it, and then commits by actually delivering the pizza.
All right, let's dive into that first part of the process, building the blueprint. We're going to cover those first 3 steps, the trigger that gets everything started, the creation of that virtual DOM, and the super smart comparison process called diffing.
It all starts right here, with the trigger. Doesn't matter if you're in an old class component using this.state or a modern functional component with a hook like setCount or even useReducer. These commands are the starting gun. They're what tells React, hey, pay attention, something changed. It's time to kick off the update process. So this is a crucial point, and it's a classic interview question. What actually starts a re-render in React? The answer is really simple, and you should know it by heart. It's one of 3 things: a change in that component's own state, a change in the props it gets from a parent, or a change in a context value it's listening to. That's the whole list. So once that render is triggered, React immediately moves on to step 2, creating the virtual DOM. Now, a really common mistake is to think the VDOM is a copy of the real DOM. It's not. A much better way to think about it is as an architect's blueprint. It's just a lightweight description, a plain old JavaScript object of what the UI should look like. And because it's just an object, it is incredibly cheap and fast to create and mess with, unlike the real DOM, which is notoriously slow. And this is literally what that blueprint looks like. When React runs your component function, like this user card here, it doesn't create real DOM elements. Nope, it just returns a simple JavaScript object that describes what should be there. Something like this: type, h2, children, John. This whole process is lightning fast because we're just creating objects in memory. We haven't even touched the browser yet.
Okay, so React has the old blueprint, and it just made a new one. What's next? Well, this brings us to step 3, diffing. And this, my friends, is React's secret sauce for performance. It's the process of comparing that new VDOM tree with the old one to find the absolute minimum number of changes that need to be made.
And the scale of this optimization is just staggering. Seriously, a basic, naive way to compare 2 trees has a complexity of O(n) cubed. So for a UI with just 1,000 elements, that's 1 billion operations. That's impossibly slow. But React's diffing algorithm, it works in O(n) time. That's linear time. For those same 1,000 nodes, it's just 1,000 operations. That's the magic right there. That's what makes React feel so instantaneous. So how does it pull off this incredible speed boost? It uses a few really smart shortcuts or heuristics. First, if an element's type changes, like a div becomes a span, React doesn't even bother comparing them. It just throws the old one out and builds a new one. Easy. Second, if the element types are the same, it keeps the component and just updates its attributes. And third, and this is a big one, for lists of items, it uses that special key prop to quickly match up the children between renders. And that brings us to the perfect gold star interview answer for why are keys so important. You say this: keys give list elements a stable identity. This lets React track items that are added, removed, or reordered in linear time.
Without keys, React is forced to guess, which often leads to it destroying and recreating components when it doesn't need to, which is slow and can lead to some really nasty bugs with state.
Okay, so after the diffing, React knows exactly what has changed. The next step is figuring out how to actually apply those changes. And this brings us to step 4, reconciliation. Its modern engine for this is called Fiber, and this is where React does something brilliant. It separates the planning from the doing.
This is a really important distinction to get. The virtual DOM is the what. It's the blueprint, right? The description of the UI. Fiber is the how. Think of Fiber as the project manager and the construction crew. It takes the blueprint, figures out the work schedule, and then actually gets the job done. It's the engine that powers reconciliation.
Now, the truly genius part about Fiber is that it splits all its work into 2 very distinct phases. You've got the render phase, which is all about planning. It's asynchronous and, most importantly, it can be interrupted. Then you have the commit phase. This is all about action. It's synchronous and it cannot be interrupted. This separation is the key to how React stays so snappy and responsive. So, during that interruptible render phase, React is busy doing all the prep work. It's calling your component functions to get that new VDOM, it's building its internal Fiber tree, and it's figuring out exactly which DOM operations are needed. It compiles all this work into a to-do list, which it calls a list of effects. And the critical rule here, the one you must never break, is that this phase has to be pure. No side effects, no API calls, no messing with the DOM directly, just calculation. Once that plan is complete, Fiber finally moves to the commit phase, and this is where the action happens. It takes that to-do list of effects and just runs through it, updating the real DOM. This phase is fast, it's synchronous, and it's all or nothing. It also runs lifecycle methods you might know, like useLayoutEffect. This is what we call the synchronization boundary. It's the precise moment the virtual blueprint becomes a real, tangible thing in the browser.
And this leads us to another one of those expert-level interview answers. If someone asks you where you should measure a DOM element's size or position, here's what you say. You should do it in useLayoutEffect. Why? Because it runs synchronously during the commit phase, right after React has updated the DOM but before the browser has actually painted the changes to the screen. This guarantees you're measuring the final correct layout. If you try to do it during the render phase, you might get old, stale data from the previous render.
All right, let's bring it all home. Let's focus on how to nail these concepts if they come up in an interview. We'll do a rapid-fire review of the most critical things you need to remember. Here's probably one of the most important questions you could get. It really tests if you understand Fiber's core design. Can that final, action-packed commit phase be paused or interrupted for any reason? And the answer is a firm, confident no. The commit phase is synchronous and cannot be interrupted. It has to be this way to prevent the user from ever seeing a half-updated, broken, or janky-looking UI. Only the planning part, the render phase, can be interrupted, and that allows React to pause what it's doing to handle something more urgent, like the user typing into an input field. So let's run through that whole journey one last time, just to lock it in. 1. A trigger, like a state or prop change, happens. 2. React builds a new VDOM blueprint. 3. It efficiently diffs the new and old blueprints. 4. The Fiber reconciler plans all the necessary changes during the interruptible render phase. And 5. It applies those changes to the real DOM during the synchronous, uninterruptible commit phase.
And we'll end with a little brain teaser for you. You now have a really solid mental model of how the React lifecycle is supposed to work. But the next step in really mastering a system is understanding how it can fail. So think about it. Based on all these rules we just talked about, especially the ones about pure render phases and synchronous commits, how could you intentionally write code that breaks this lifecycle? That's the kind of question that really gets you thinking like a senior engineer.